Welcome to Slope and Rate of Change. This is lesson 6.1. Our goal is to find the rate of change from tables, graphs, and find slope. So slope is the rate of change, the rise over the run, or the steepness of a line. To find slope, we take the vertical change divided by the horizontal change, the rise over the run, or the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1, where, note, x sub 2 minus x sub 1 should not equal 0, and we'll get into that a little later. So slopes of lines, a line that slants up from left to right is positive slope. A slope that slants down from left to right is a negative slope. We also have two other types of slope. We have a line with a slope of 0 is horizontal or flat. So the slope is 0. Please avoid saying no slope. It does have a slope. It has a slope of 0. And again, we'll talk about 0 being a number, so don't forget that. Now, when we have a vertical line, a line that goes straight up and down, that slope is what we call undefined. And if you think about your x and y values here, your y values are not going to change, right? If you have a vertical line, so a line that is going straight up and down, if it fails the vertical line test, so it's not technically a function, and the slope is undefined. We don't call it no slope. We don't call it 0. It is undefined because we're dividing by 0. Once we get into the formula, you'll see that. So let's go back and try to find the rate of change using a table. So with a table of values, remember, if something is linear, it's going to have a constant rate of change. And so any 2 points in your table should have the same rate of change. So if we look here, we're going from $30 to $42. So that is an increase of $12, right? And over here, our run, or our miles in this case, is increasing by 50. So our slope is $12 over 50 miles, right? So if we then divide that, we get the decimal 0.24. So that is 24 cents per mile. So that's our rate of change. And we can check that by looking at the rate of change. Let's just jump to 200 miles to 250. And over here, we jump 54 to 66. So again, we have that same 12, the rise, the change in the dependent value, which is fees, divided by the change in the miles, which is 50. And so we still have that constant rate of change, which is 24 cents per mile. Here's our slope. So we're going to find the slope of our line. And again, slope is the change in y by the change in x. If we look at our first graph here, I'm going to use a red pen, make sure I have a red pen. Our change here is we're not going up, we're actually going down. So remember, our change, our vertical change divided by our horizontal change. So in this case, we are going from 4 to 1. So we are going down 3, and then we're going from 0 to 2 in our point, so that is 2. So our rise over our run is -3 over 2, and you can just leave that as a fraction, an improper fraction. Don't write a mixed number. It's completely acceptable to just say -2 or -3 halves. In example B, our rise, here we're going up and over, so we are going up, unlike the last problem in which we were going down from left to right. So we're rising from -1 to 1. So we're rising 2, and we are running from -2 to -1, so we're running 1. So our slope is just 2 over 1, which is 2. Notice how in this example, I drew my triangle a little differently, but the rise and the run are still the same. You can draw any triangle using 2 points on any portion of that line, and the slope will still always be the same. That's that constant rate of change, or that slope. In our last example, we're going to use our formula here. Now, so our formula, if you recall at the beginning when we were talking about our vocabulary, it's y2 minus y1 over x2 minus x1. Those 2's and 1's just refer to which point you're talking about. In this case, it's not going to really matter which you call point 1 and which you call point 2. Just remember to be consistent as you're calling them. So I'm going to call this point 1 and this F point 2 just for now. If you would like to try this with the reverse, calling E point 2 and F point 1, go ahead. And again, trust me, it's going to give you the same slope. So all we're going to do now is the Y value of our second point is -1. So I'm going to put that in there. And then it's minus the Y value of our first point, which is -2. And I'm going to put that in parentheses to just keep track of my negative signs because I have those double negatives there. Got to watch your integers. And then that's going to be all over the X value from point 2, which is -2. Okay, and then minus, again, subtracting. In this case, we're minusing 3. And I'm just going to throw that in a parenthesis just for consistency. So now I can simplify my numerator and my denominator. So I have 1 minus a -2, which becomes -1 plus 2, which is -1 plus 2 is +1, over -2 minus 3, or minus a +3, which gives me -5. So my slope is -1/5. And a habit I want you to get into is always, 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 if you've got a negative fraction, always make it the numerator holding that negative sign. Don't put it out front. Don't leave it in the denominator. You're just less likely to lose it and forget about it if it's in that numerator. Again, just another good habit to get into.